Robots have brought about more productive manufacturing lines and greater quality assurance. Their use has saved people from having to work in hot, toxic, or otherwise dangerous environments. Automated production lines using robots are chalking up an admirable safety record. However, industrial robots have injured people, and injuries may occur more frequently as the number of working robots increases. In at least one case in 1984, a worker was killed. The victim entered the working range of the robot, presumably to clean up scrap metal that had accumulated on the floor. The work cell control systems did not sense his presence, and as a result, the worker was pinned between the back end of the robot and a steel safety pole. His heart stopped. No matter how automated a manufacturing line is, there are sure to be workers around who must be protected. Line operators. Maintenance workers. Programmers. Managers and visitors. Robots have weak sensing capabilities, so they can't be relied upon to always react in a safe way when these workers approach. Safeguarding robots is more complex than safeguarding other types of machines. Their range of movement is much greater than other machines. Machine guards around belts, other moving parts, and points of operation are small in comparison to robotic work cells that often encompass several cubic yards on the plant floor. Robot guarding has to be flexible, too, to adapt to the variety of tasks a single robot may perform.
でしょうか。はい。じゃあ、Good morning. Let's start today's class. Thank you for attending here. And this video is by U.S. National Institute of Occupational Safety and Health, NIOSH, to U.S. governmental organization. This movie has published on 1989. It means more than 35 years ago. And yes, it says the industrial robot has been widely used. And one accident here, some worker is killed by a robot, industrial robot. So therefore, that is a very, very big issue for engineers and also the users. Yes, come on, and please connect the Zoom system as soon as possible. Yes. So therefore, the safety, occupational health, and the safety is occupational health and safety is very, very important for any people, workers, engineers. And this video shows line workers and the maintenance people and also the managers, visitors is also the very important because the robot is moving so fast rather than the human being. And the robot makes a very larger power than human being. So therefore, that is very, very dangerous machine, dangerous object. So therefore, this kind of thing, yes, before that time, this kind of the covering, the rotating portion and the moving portion has been covered by this kind of mesh or some guard system. It looks like them for the industrial robot. The fence, guard fence is necessary to prepare to prevent the working space of robot and the human worker must be clearly separated. So that is a very important first concept for this kind of thing. And then when someone is programming it or maintenance it or working it, some sensor must be working. So the safety system has been generally developed. So this is the story of this kind of work. So today's topic is focusing on the safety. as you have studied. This is the second part of this 3-week series. The last week, the dependability or human error we have discussed, and then today is safety, and the next week is friendliness. And this today's contents has many topics inside of it. But the one of them is mostly about the general robot and general machinery's safety concept and details which we have to learn. And then the coexistence system, it means recently the cobot, collaborative robot with human being, has been widely used in many manufacturing sites and places. So therefore, this kind of collaborative cobot systems safety we have to consider. And some other appendix part is also there. Mainly, separated into two parts. One is machine safety and also the collaborative robot safety. But this safety part is very wide range of topics is included. And I want to know what you have learned and also what you have not understood well or which part you haven't understood well or something. And for examples, I have given some topic questions about it. ISO, IEC. Chena, what is ISO? Okay, and what is the difference between the ISO and the IEC? Yeah, no. 本当やってる。ハオシャン、what is the difference between the ISO and IEC? Okay. Almost okay. That is, as I have introduced in this page, ISO is mainly for the machinery product, but IEC is mainly for the electric or electronical products. IEC は not European, Electrotechnical Commission, International. Okay. Yes. And then in any product, machinery product, electrical product, the guide 51 differs. 51 is the most important point of so therefore you have to understood well is a first question. And next is second question is safety. What is safety? And what is the difference between hazard, harm, and something? Yes. Harm and hazard difference we want to discuss. We want to understood well. And the safety procedure, one of the risk reduction, and another one is risk assessment. And also the cobot is become familiar for industries. So therefore the AI technology will be used has been used in the cobot system. So therefore what it It's that we want to know, we want to understand. It's the today's challenge for preliminary studies for you. But not only this 5 questions is not covering in today's topic. So therefore, any part you want to know more or you want to discuss more or something. So we want to hear from you about the interest or difficulties or not good enough understood or something. So please tell us about your interest. Yes. じゃあ、how about UA? What is your interesting part or something you want to know more or you haven't understood well or something? Any part is okay in this material. Which part you want to discuss more or you want to hear others answer or something? Which part? ちょっとリスクリダクションパート。リスクリダクションってどこなのかな？リスクリダクションっていうのは、これだと Q3 ってことか。Q3 パート。Q3 part risk reduction. Why you want to know about it? And what is the present understanding?
Because it's executive stage of how to reduce the risk, and it helps us prevent from the machine failure.
Okay. This is how to reduce risk is related to the prevent machine failure か。はいはい。Yes, thank you. Thank you for your question, for your answer. ちょっとじゃあ、how about Ihan's answer? That is, which part you are interested in or which part you want to know more or なんか which part you want to hear others answer?
I'm interested in the part 3, the definition of risk and the outline of the risk reduction. So I find it a very, very good question. So because the risk is a abstract concept in our daily life, but it uses a mathematical expression to abstract the concept. So the mathematical expression is risk equals severity multiplied the probability. So I think it shows a good way to generalize abstract concept in our daily life.
Generalization and common concept. Generalization. So, common. はい。はい。Jenna.
Okay. I preference the question 5 to list and explain the context of safety technology to realize robots. In addition, list and explain AI technologies which contribute to global safety. Because the global safety is actually an interesting part of nowadays human-computer interactions. And for the robot safety, there is something definitely new to explain and tell something about it.
Okay. Good application. Cobot is a very good application for the collaborative work between the human and machine, and also the new technology has been applied to here.
Especially in the service for the services because of actually for the services, the sale, the restaurants, there are lots of places that the output, the production is not standard. This in the far future still need people to direct the need of the direct the need of the professionals. So the cooperate of the robots never been will never die.
レストランサービスロボット。
So the active safety is fairly important
Okay.
for the
Okay. Such as restaurant service robot. Restaurant service robot is, in many cases, food delivery robot. はい。Thank you. Thank you. How about Hawking? Hao さん。
Okay.
What is your interest or which part you are?
Yeah, that's I'm more interested about the question 5. I'm also interested about the co robots, collaborative robots. I mean, in the question, I know that the AI technologies nowadays are using for the cobots, but I don't very clearly know about the example of the using. Because in my opinion, I think that the cobots is used for do some repeatable work for human when in the industry or somewhere else. I think this kind of work maybe don't need the AI, so I don't know very clearly about the AI usage of the cobots. Hi.
So, Mr. Roy Fan, could you please show your understanding of risk assessment?
So most of the content is from the ISO 12100. So to implement risk assessment and risk reduction, the designer should take the following actions in the order given. So first, determine the limits of the machinery, which include the intended use and any reasonably foreseeable misuse thereof. Identify the hazard and associated hazard situations, estimate the risk for each identified hazard and hazard situation, evaluate the risk and take decisions about the need for risk reduction, eliminate the hazard or reduce the risk associated with the hazard by means of protective measures. So action A to D are related to risk assessment and E to risk reduction. Risk assessment is a series of logical steps to enable in a systematic way the analysis and evaluation of the risks associated with machinery. Risk assessment is followed whenever necessary by risk reduction. Iteration of this process can be necessary to eliminate hazards as far as practicable and to adequately reduce risks by the implementation of protective measures. It is assumed that when present on machinery, a hazard will sooner or later lead to harm if no protective measure or measures have been implemented. Example of hazards are given. Protective measures are the combination of the measures implemented by the designer and the user in according with this figure. Measures which can be incorporated at the design stage are preferable to those implemented by the user and usually prove more effective. The objective to be met is the greatest practical risk reduction, taking into account the four below factors. The strategy defining the clause is represented by the flow chart. The process itself is iterative and several successive applications can be necessary to reduce the risk, making the best use of available technology. In carrying out this process, it is necessary to take into account these four factors in the following order of preference: safety of the machine during all the phases of its life cycle, the ability of the machine to perform its function, the usability of the machine, the manufacturing operational and dismantling cost of the machine. So this is the figure of the risk reduction process in the ISO 12100. That's all. Most of the answer of this part is from the ISO 12100.
Oh, you found, no, you have found some original rules or
original manuscript of this ISO number.
Yes.
Please show us which part you have found this original.
Almost most of the answer is from the original, the ISO 12100 file.
You can introduce the website of this original manuscript of this rule.
Oh, yes, yes.
どっかにある。freely. You can find the freely. You can get something freely. This.
Sorry.
これってオリジナルってないんだっけ？なんか、どっかで。
I'll share the file.
Okay. Not only the file, but you should show if you have something, address. これは this isこの DS、これ this is the one of the explanation of this ISO based on this.
Yes. And my answer is from the.
でも this is also the original one. This is showing English version. Yes. で、これの this PDS EN ISO のこれの this is original address. You can show?
And
これどこにあるんだっけ？ BS なんたらかんたらの。これだ。other student also has found this original one? Yes. これ。BS なんたらかんたら。で、
So my answer is most from the page 9.
Yes. これも same だ。これ same。あおちゃん also found this material? Okay. Yes. From this, なんだっけ？これのページ9か。Page 9 is the important chart. The safety for risk assessment and risk reduction strategy ね。Yes. This chart shows that. On page 10, the chart shows the schematic representation of risk reduction process, including the iterative three-step method. And also the following part is also the important risk reduction process from point of view of danger. Step 1, Step 2, Step 3. Yes. Good. Hi. Thank you. If you found the original one, you may be able to study a lot from here. Yes, thank you.
Thank you.
はい、じゃあちょっと今、オリジナルペーパー、he has shared, but how about the next student?
Sure. Next, Mr. Chen Yuwei-san, could you please show your answer?
On the ISO 12100, a systematic five-step risk assessment procedure is used to ensure machine safety. Determination of the limits of the machinery. Machines must prioritize safety, usability, and productivity. A risk assessment evaluates these factors to define operational constraints. These constraints fall into three categories: usage limits, spatial limits, and temporal limits. Usage limits Machine operation modes and user intervention procedures vary based on design and application. User-specific restrictions may apply to individuals of certain genders, ages, or physical capability. Operator qualification depend on training, experience, and skill level. These factors consider both intended use and reasonable foreseeable misuse. Intended use refers to operating the machine as specific in the manufacturer's instruction. Reasonably feasible misuse occurs when users operate the machine incorrectly due to predictable human behavior. Visual limits. Machine movement range, such as robotic arm reach or frame mobility, defines operational boundaries. Work area design ensures safe zones for operators during normal use or maintenance. Operator machine positioning affects interaction efficiency and safety. Machine power interface must comply with safety standards. Temporal limits. Machine or component lifespan varies. Examples include cutting for edges, filters, lubricants, and switch contacts. Scheduled maintenance intervals ensure optimal performance and longevity. The hazard identification plays a critical role in risk assessment. Overlooking hazards may lead to unsafe machine operation, increasing the likelihood of severe accidents. Hazards can be classified into different types, including mechanical, electrical, thermal, noise, vibration, radiation, material substance, ergonomic, environmental, and combined hazards. Each type presents unique risks that requires through evaluation. These considerations in hazard identification include prioritizing serious hazard, recognizing permanent hazard, and address accidental hazard. Health-related hazards demand special attention due to their cumulative effect over time. Effective identification methods include the hazard listing approach, which examines risk across all operational phases, and work analysis, which assesses hazards based on workflow. The utility tracing method focuses on energy-related use, such as electrical or pneumatic systems. Regardless of the method, referencing standard hazard lists ensures comprehensive risk detection. Additionally, different work scenarios may transform a single hazard into multiple hazardous events, requiring tailored protective measures. Existing safeguards should also be reviewed to ensure they do not introduce new risks by systematically identifying and addressing hazards. Organizations can enhance machine safety and prevent accidents. On the risk component, risk combines the severity of harm and probability of harm occurrence. The probability depends on 4 factors: likelihood of a hazard event, frequency of exposure to the hazard, the duration of exposure, the possibility of avoiding harm. ISO 12100 does not define specific criteria, but standardized methods help ensure consistency in risk evaluation. Methods for risk estimation. Several approaches assess risk, including summation multiplication method, assigns scores to risk elements and combines them through addition or multiplication. Risk matrix method plots the severity against probability on a grid to visualize risk level. Risk graph method evaluates severity, exposure frequency, and avoidance possibility in a structured decision-tree hybrid measure merges the machine and risk graph techniques, often used for determining safety integrity level. Evaluating severity of harm. Severity is categorized into 4 levels: lethal or irreversible injuries, major injuries allowing work continuation after recovery, reversible injuries requiring medical treatment, minor injuries treatable with first aid, assessing probability of harm. These factors determine likelihood, exposure levels, ranges from continuous to rare, probability of hazardous events, risk failure, likelihood from very high to negligible, avoidance possibility, access whether workers can escape harm, determine safety integrity levels, a structured approach aligns SIL by cross-referencing severity and probability. Higher severity and likelihood demonstrate safety control. Once risk estimation is finalized, the next step involves evaluating whether the identified risk requires mitigation. If the assessment reveals that the risk exceeds an acceptable threshold, appropriate risk reduction strategies must be implemented using a 3-step method. When introducing new protective measures, it is crucial to verify that these interventions do not introduce additional hazards or inadvertently evaluate other risks. Should any new
International safety standards, including ISO 12100, do not prescribe specific tolerable risk thresholds. However, organizations must establish their own acceptable risk criteria before initializing risk assessments. Changing these tolerance levels mid-assessment can disrupt previously implemented safeguards, leading to inconsistencies in safety measures. By setting clear risk acceptance benchmarks early, companies ensure a structured and reliable approach to risk management, minimizing potential oversights and maintaining workplace safe standards. Apply risk reduction measures. It includes the inherently safe design principles. Manufacturers must integrate safety into machine design by considering geometric and physical factors. Key approaches include the geometric optimization, positioning hazard zones within the operator's line of sight and eliminating sharp edges. Physical safety measures, reducing actuating forces, minimize noise, vibration emissions, and substituting hazardous materials. The ergonomic compliance, ensuring controls and workstation prevent strain, fatigue, and unsafe postures. Control system safety, preventing unintended startups, ensuring fail-safe power interruptions, and restricting unauthorized software modification. The safeguarding through isolation and stopping. The protective measures focus on physical barriers and automatic stop mechanisms, a fixed and movable guard, permanently block access or interlock with machine controls to halt operation when opened. The sensitive protective equipment, light curtains, laser scanners, and pressure mats detect intrusions and trigger shutdowns. The emergency stop functions require clearly marked, easily accessible actuators and maintain a stop state until manually reset. The complementary protective measures, additional safety adjust risks, residual risks, emergency escape and rescue, provide clear exit passes, manual override controls, and a communication system, energy isolation, enable complete power disconnection and dissipation of stored energy for maintenance safety, safe access and handling, incorporate non-slip surfaces, lifting aids, and for prevention for evaluated work areas, risk communication via user information, clear instructions and warning ensure safe operation, warning signals, use audible visual alarms that precede hazards and remain noticeable without causing desensitization. Labels and manuals display hazard pictograms, multilingual warnings, and detailed procedures for installation, operation, and maintenance. By combining inherent design safety, engineered safeguards, and user awareness, manufacturers can systematically mitigate risks while maintaining operational efficiency.
That's all?
Yeah.
Please show your references. Which part mainly you have referred? Can you share this on the meeting chat box? Oh, yes. これ何? Only this?
Yes.
このなんか in your reporting, the table 1, table 2, table 3 you have mentioned, but this is all of them is from this
Yes.
material?
Yes. The original of the ISO.
これ this is the IDEC っていう this company's this safety なんか system the company is making this なんか summarization テーブルってある？まあ this is following the all of this ISO 12100's the summary is given in here. Table 1, 2, 3これか。Example of risk elements and point allocation. まあ、point setting is very different for individuals. So, これ、fatal, 例えば、for example, the fatal wound is 10, severe injury is 6, and moderate injury is 3. But this is not so much common, I think. For example, the table 3, I have to share this table 3ってのちょっと待って、これじゃなくて、yes, この、you are referencing only this, IDEX, sites, the explanation. Well, it's good. You found the good explanation site by this company. It's okay. Yes, but from the beginning, yes, this shows this kind of outline of this assessment procedure. Looks like this is okay, good. ちょっとでっかくして。これ文字はでかくなってる。図はでかくならないのか。It is difficult to make it more larger. Procedure 1 is determination of the limit of the machinery. Procedure 2 is hazard identification. And procedure 3 is risk estimation. This part is risk analysis. And the risk evaluation part, including it, is a risk assessment. It says, and the risk reduction part is step 1, step 2, step 3 is inherent safe design measures, and also the step 2 is safeguard and comprehensive protective measures, and information for users is step 3. This is a risk reduction procedure. It says, well, that is good summary for these activities. Flow of risk assessment, risk reduction, it says, well, it's good. And also yes, this is the same as similar to the ISO. The scope is step 1, 2, 3. Inherent self-design measures, safeguard, complementary protective measures, information for users. But also the other activity is also protective measures implemented by users, including those based on the information for user provided by the designer. So, for example, the workers' training or something is also the important. Manual preparation is also the important, it says. Sure. いや、これ、リスクは hard and the probability happen, occurrence happening is the multiple part is here, risk って書いてある。あと、this numerical one is, この score is not so much the commonly used, but, you can find the relative magnitude of this, the fatal error とか fatal injury とか severe injury とか moderate injury, this kind of the severity of harm is scored like this, and the probability of happening occurrence is also the like this, so you can find frequency of exposure is also here, and the example of risk matrix. This is also the one researchers or some organizations saying leaflet of guideline for risk assessment by Ministry Health, Labor and Welfare. Maybe this is US organizations, some guideline is saying like this. And others, this is the same, similar, and this is a similar way to find this. But for example, the QA, which part is the most important to you think in this material? What do you have? What do you have understood, and what is the most important point of this material? Say, how do you think?
I think it is the risk estimation.
Risk estimation. In fact, what is the risk estimation?
Understanding the risk components.
Understand risk components. Understanding.
And estimate how much it is risk.
それは、quantitativity だよね。make it quantitative value, something. Just for engineer's viewpoint, which part is most important, you think? For engineers, if you design some product, which part is very, very important for engineers to design some product or manufacturing some product? How do you think?
You control the risk.
Show the risk, but how to show the risk? How to find the risk?
Through the 4 methods.
4 methods. What's 4 methods?
The summation multiplication method, risk matrix method, risk graph method, and hybrid method.
ここに、この this material showing some the methodology of finding the risk. どこにあります ?Here. これ 3 risk estimation. これ this part?
Yes.
で、ここも、なんだっけ。1, 2, 3. これか。severity of harm at the relevant hazards というやつ。hybrid method based on なんたらかんたらかんたら。This set is this method is considered to be combining the summation method and risk graph method. It is used to estimate the safety integrity level and the safety relative part of the control system. これは after the なんか、ハザードソースとか、ハザードソース is identified. And so in that case, we can design some like safety measures like this by using this. It's saying this. まあいいや。まあ、はい。Thank you for your reporting. You found one good sources, information source. But I hope not only relying on the one source, but you also compare to the other, for example, other manufacturers' safety information cited also you should explore, and then the comparatively or summation or summarizing the 2 or 3 information source and then making some report. So not only relying on the one information source, I hope. But this is on one site, good site, okay. But also you should find another site to another company or another manufacturing is exploring or expressing in a different way. So therefore, you should also need other site also, I hope. はい。じゃあ、Thank you. Your work is maybe, ちょっと待って。My note は、まあ、Ifan は looking this. Okay. And how じゃねえ、これ。UA か。UA is also showing this site. Looking this site. これはまあ、IDEC っていう、this なんか safety switch とか safety systems manufacturing safety company ってことね。はい、OK。はい、Thank you. The next.
Yes. Next, Mr. Guo Haochen, could you please show your answer?
そうです。はい。ミュート、まだ、直しちゃった。はい。
Question 4. Explain the risk assessment procedure under ISO 12100, where the safety of machines can be determined in 5 steps. And it have the 5 types of the risk assessment procedure. Firstly is the determination of the limits of the machine. It is that where the machine will be used and who will use it, and what will it will be used for. Questions such as this. And secondly is the hazard identification. Identification is that identified all possible hazards arising from mechanical, electrical, thermal, ergonomic, chemical, or something else. And in this type, we should consider normal and abnormal situations. And secondly is the risk estimation. It is It is that assess the risk level. Sorry. It is that assess the risk level for each hazard based on the severity of potential harm, probability of occurrence, and the frequency and the duration of exposure, and the possibility of avoiding the harm. This is 4 point. And the first type is that risk evaluation. It is that compare e- estimate as estimated risks to acceptability criteria to determine if risk reduction is needed, and identify which risks are acceptable and which must be reduced. And finally is the risk reduction. Risk reduction. It is that apply the following hierarchy of controls. Inherently safe design than the protective measures. And then the information for use. It is three methods. For example, it is in some safeguards, for example, walls and doors on, and this is hiding the worms for the workers, for example, the aim is to eliminate or minimize risks to an acceptable level. OK, 以上です。
うん。で、これどこレファレンス。What is the reference?
Reference here. I also found some page, but it is a preview. It is a preview. It is a preview, and it is just stop at the lab page.
Not the covering all the pages, only the some several pages, right?
そうだ。
これ、そうなんだよね。だから、if you access in this standard site, this only shows only first several pages. But the other, if you explore more, you may be able to find the full pages of this standard. So therefore, you should find more. You should explore more. Or as UA set, UA done, the exploring others manufacturing explanation side or something. It's also the covering all of the, not directly showing the ISO's this safety rules directly, but the some explanation based on that standard is also shown on some manufacturer site. So therefore, you should refer more about it. Okay?
OK, I know.
はいはい。じゃあ、Thank you. じゃあ、finally,
General.
Yes.
I have the same reference as the Luo's reference, and I actually pay more attention to the original sentences of itself. For the definition and the purpose of risk assessment, we could according that it's a series of logical steps to enable in a systemic way the analysis and evaluation of the risk associated with machinery. And we could say the purpose is determine whether risk reduction is reduced to the document and process clearly the future review. And we also could find that a powerful word that it is freedom from the unaccepted risk. The freedom from is it's a negative freedom. It is about that we have the we have to obey. We have the we have the obligation of to make sure that we avoiding the acceptable risk. It is fairly interesting word to using it. And we also could find the later to determine the limits of machinery to make us to five steps to risk assessment. The first step is determining of the limit of the machinery. Why we should determine? Because if we don't know what is the limits, we even cannot to calculate, cannot to define what we should avoid. So we could in intensity to use the reasonable force symbol me use to count the space and time related limits and the environmental limits. The limit, and there is the original word, the limit shall include the limits of the use, space, time, and other constraints. And also we need to identify the hazards. We only firstly understand the category of the hazards. We could try to find the every part of the machinery we how to avoid the risks. As we could find the original word, hazard shall be identified for all tasks associated with each phase of the machine life cycle. Right, it's not only the part, also the machine using time. And the step 3, risk estimation. We get information from the part 1 and part 2. We finally could calculate it. And there is also an original word called the risk estimation shall be carried out for each hazardous situations. And also for the we could also to the evaluation the risk as we have already estimated. We could define that the risk evaluation shall determine whether the risk reduction is required by have already estimated. For the finally, we get the all step assumptions and the results should be clearly documented. As we have remembered, we have write down what is what risk could be found and how to avoid them. So this step, the original word is the result of the risk assessment shall be documented. This is all from the original word. I accordingly augmented to it and didn't say anything except it.
Okay, and this novelcert.com.
Right. This is a website that provides the original word of the ISO 12100.
これでね、this is good to find the all of the ISO you can read from this site.
Right.
Okay, good. And you also said 5 steps, but for engineer's viewpoint, which part is the important and which is the difficult?
I think the mostly important part is actually the documentation of the process, actually, because we could all find them, but usually when we make a design, we don't prefer to write down everything. We hate to write down the document. However, for a real engineering design, we should write down the document. This is actually a reverse to our human intensity. We human don't like to do this kind of documentation. And what is the most difficult, I think, is to identification of the hazard in every part because we should take care of every kind of risk. It is fairly difficult to us to make sure that every part, every time period of our machinery could do some kind of risk, and it means that we should need someone who doesn't really design that machine and to calculate to identify the risk, the parts and the time period that could happen, because the designer himself or herself could ignore something of it as they have the original thinking of their design.
Good answer. Yes. Hazard identification is the most
Reliable.
difficult
Right.
and the most important to start. Yes. Documentation or some information announcement for the users is the final part after doing everything, all of this.
However, it is the most important because everyone hates the documentation.
Okay. But the
hazard identification is the most difficult.
yes, as saying in this material here,
also this ISO number showing that the harm and hazards, the difference of the harm and hazards. Harm is the injury itself or damage itself to the health of people or damage to the environment.
This is okay, good for this is also the injury or damage is a harm. It's okay. But the hazard is a potential source of harm, it says. And then the following, the various kind of hazard sources there, this ISO is explaining. But only listing up this and also this IDEX is also the showing procedure to the hazard identification. Hazard situation, hazard event is the showing like this table. List of typical hazard type is like this. The origin is here, potential consequences here. This is the first category is mechanical hazards, electrical hazards, thermal hazards, noise hazards. This list we can do this listing up. But actually finding some when you show some machine, when you show some product, when you looking the manufacturing system, where is the hazard source? This finding and identify is a very, very big problem. And but the engineers must do it. And then therefore some kind of methodology of hazard identification has been proposed like this. And also I show in my material is also introducing some methodology like, yes, hazard identification technique, process hazard identification, hardware hazard identification, control hazard identification method, human hazard identification method, the various techniques. Yes, for example, the most famous one is HAZOP, hazards and operability study. HAZOP is one important and the famous methodology for hazard identification. ちょっと HAZOP とか言って、if you explore this on site, for example, HAZOP って言うと、なんか何が出てくるの？これ日本語しか出てくる。HAZOP。Appendix HAZOP。まあ、なんかさ、ちょっと、ウィキペディアの英語版を探せるか。ウィキペディアで英語版。はい。English。ね。Hazard and operability study. Hazard is structured and the systematic systematic examination of a complex system, usually a process facility, in order to identify the hazards to personnel, equipment, or the environment, as well as operability problems that could affect operations effectively. It is famous hazard identification tool in the domain of process safety. Process engineering, the hazard is the famous one to use. For performance identification tool is that identifying performing the hazard is a review of the design to pick up design and engineering issue for. So therefore, it shows many people is concerning how to find the hazard source, which part is the dangerous source that we want to know. So therefore, some tools is also the developed to find the hazard source. So yes. So therefore, this slide it introduce various way of ちょっと hazard identification techniques とかなんか言うと、maybe that you may be able to find the various method. とってもこれで、なんか、すぐに日本語だと hazard identification technique. I don't know that this is good. Whether this is good site or not, but maybe the tools hazard is yes この hazard とかね。あと failure mode and effects analysis が FMEA とかjob safety analysis とかもう this is a human jobs the safety analysis とか this kind of the techniques is also shown also the developed up to here, up to now. The safety hazards identification assessment action item. 書いてある。Recommended practical for safety and health progress. Hazards identification assessment. Identification is important, it says maybe. でも、なんか、identification、これ、トゥールとかやる。tools. なんか various tools you may be able to find. さあ、hazard identification training tool とか、hazard identification tools, maybe. カナダ、ケベック。あれ。時間かかったですね。いいよ。よくわかんないけど。hazard identification tool. で、the information on this page help. いや、なんか、hazard tool. 全然ダメだ。not more direct information. ちょっと違う。hazard identification tools. これさっきと同じ？さっきと同じか。これ同じか。同じだな。はい。ということで、you may be able to find the various kind of tools and because the engineers, when you design some product, engineer must estimate the users using situation or the conditions, environment conditions, and the operation way or something, the various kind of the situation and various kind of usage you have to estimate. And then the which part will become the potential harm, potential source of harm we want to find. So therefore this is only the general term it is said, but practically applied to this, it is very important. The engineers must estimate who will use and which condition this user will use and how to use. The various kind of the factors you have to estimate. And then this hazards identification must be done. Mechanical hazard, electrical, thermal hazard と書いてあるけど、various kind of hazards is there, and then you have to estimate. You have to estimate and to identify. After identification has been done, the estimation, risk estimation, risk evaluation, risk reduction process, you'll be able to do. But if you miss this identification, this process hasn't been done, so therefore it will become remaining for users from this product or from this system. So therefore, firstly, this identification part is very, very important. You must understand. はい。で、this isなんだっけ? I have asked about this question 4. So therefore, the next to the reduction part, you are interested in about the reduction part. So therefore, to move to the question 3's answers, Pension, please do.
Yes. So Mr. Zhang Zhen also, could you please show your answer?
Sorry. You have to.
Okay. What happened? It is question 3, right?
Yes.
For the first definition of risk in ISO IEC Guide 51, I actually also get the original documents, so that's why I don't pay attention to what is IEC as the original I also combined with the original document and definitely based on the original word. First, the combination of the probability of occurrence of harm and the severity of that harm. It is the risk for the original word. So this is for the risk. It is not the harm itself. It's a possibility. To define emphasis of it is not absolute. It depends on how likely an event is to occur and how severe that conquered are. The dual factor understanding forms of the basis of all safety related assessment and interventions. In this framework, safety is defined as the condition to being free from the unaccepted risk. Right, the first free from. And this is also the original word. To process of the risk reduction, 3 steps to design and 1 in use. To achieve safety, it's also outlining a 4-stage risk production. These stages are constructed in hierarchical order effectiveness. And describe the section 6 of the guide. I didn't give the figure because I just think that the original word is enough, so I didn't need the figure itself. So we just to go to the steps. If someone need to see the figure, we could go back to the page 5 itself. And firstly, the inherently safe design measures, the design stage. We actually could find the original word called the inherently safe design measure should be applied to the greatest contents possible. So how to know this? There is an example and to include reducing moving part speed, changing geometry to avoid entrapment, or use low voltage designs. These are all methods that how to eliminate the hazard or reduce directly through the design on the machinery of system. The step 2 is the safe run of protective designs. It's also made in the design stage. The original word is where hazard cannot be sufficiently reduced by inherently safe design. Safeguarding shall be applied. Just if we have to use the faster rotation or high voltage, we should firstly design something to avoid it. Avoid the damage of it, and also we should to get the information for use that that the original word said information for use shall be provided if the remaining risk is not adequately controlled, as we could find that the user should know the information of the machine, don't to control the machine that without learning anything about it. It's considered the least reliable and should be used after technical measures. And for the stage 4, it's become the use stage. There's no original word for that, but we could find the residual risk may be further mitigated by user actions and organization measures. Examples include personal protective equipment. It is fairly important, especially for the developing countries, and maintenance protocols and behavior-based safety programs. The third one actually plays a key role of the manufactured industrial process. However, actually, it even didn't do well on some developed countries, just like the United States. This final stage highlights that while user responsibility matters, the design should minimize the need for it. And I used the guide of this, the Law Resource Organization PDF. It is the original page of it.
Which source you have? Please share this. This is a entire guideline is given in this.
Right. And here my keyboard then comes some errors that I could not. Wait me a while. Damn, my keyboard really have some error that I could not. I could not use the keyboard mouse, keyboard touching board.
そうなの。ちょっと、これをコピーしなきゃ、コピーっていうか、読まなきゃいけないの？
I can't select it by just touching the screen.
Others try to write on the
please somebody use OCR to input it in the chat box. Thanks a lot. There's some error happens in my computer.
Have in this S01 の IS 51の2005の PDF。ダメだ。そっか。このなんかいいな。You have access to India site. 違うのこれ。なんか、これなんだいいんじゃ、2005のインディアサイドか。本当ちょっと、others is also the find some sources about it. Okay, good. ちょっと this Indian source is not so good, maybe. Little bit old, 2005 is a little bit old, more
earlier one, the more latest one you have, maybe?
The source I share is from 2014.
2000.
2014.
Okay, yes. 私も I know about this, but I don't remember where it is. ちょっとじゃあ、next, Ethan should report about your work and also share
your
PDF file
in
the chat box.
I share the source.
No, yes, source, okay. The source is okay. これのソース、please provide us. 多分これじゃないかなと思った。これじゃないか。ISO IC Guide 55 で PDF 出れば、maybe you may be able to find some sources. これかなこれか。はい、これだ。これ、私も、yes. これ、I have found, yes. Ethan found this and also I have found this, the same one. Okay?
じゃあ、
okay, thank you.
No, I'm sorry that's in my keyboard errors.
Yes. じゃあ、next, Ethan でいい
So the first is the definition of the risk. The definition of risk in ISO Guide 51 is as follows. So the risk is a combination of the probability of occurrence of harm and the severity of that harm. This means that the risk is a function of the severity of the harm and the probability of its occurrence, which includes the exposure to the hazard, the occurrence of a hazardous event, the possibility of avoiding or limiting the harm, and it uses a mathematical expression to define the risk. The risk equals the severity multiplied the probability.
Yes.
And then the outline of the risk reduction procedure. So the most important part is the following procedure. And so the first is identify the likely users for the product or system. And the second is identify the intended use and access the reasonable forcible misuse of the product or system. And the third is identify each hazard arising in the stages and conditions for the use of the product or system. And the fourth is estimate and evaluate the risk to the affected user group arising from the hazards identified. The consideration should be given to products or systems used by different user groups. Evaluations can also be made by comparison with similar products or systems. And the final is if the risk is not tolerable, reduce the risk until it becomes tolerable. And this content is mostly from the ISO guide 55 or 51. And this is a figure. That's all.
Okay. Yes, when you find the original source of the guideline 51, you may be able to find a lot. Yes. Thank you. The next.
Next, Mr. Guo Haoquan, could you please show your answer?
Only essential part because the time is limited. Okay.
Okay. My answer of the question 3. The risk and the risk reduction. First is the definition of risk. According to the ISO 51, it is the combination of the probability of occurrence of harm and the severity of the harm. And secondly is the goal of the risk reduction. It is the goal of the risk reduction is to minimize risk to a level that is considered acceptable. And secondly is the outline of the risk reduction procedure. It have briefly 4 steps. Firstly is the inherent safe design methods, and it is that eliminate hazard by changing the design. And the secondly is the safeguarding and the complementary protective measures. For example, the guards, interlocks, and something else. And secondly is the information for use. When hazards cannot be fully eliminated or shared, provide warning. For example, the warning labels, operation instructions, and something else. And finally is for the use stage, users' behavior control, personal protective equipment. It is, for example, instructing operators to wear gloves and implementing operations protocols, training users on safety procedures. 以上です。
Okay, good. Yes. You have also found the original source of original full page. Yes.
It seems as the
Okay. Good.
original.
Yes. So therefore, you can learn a lot from this. Yes, thank you. Finally, the UA, please show briefly. Only an important part. Okay.
This is defined as a combination of the
severity of that harm, the likelihood of harm materializing encompasses strict elements, potential exposure to hazards situations, the actual manifestation of hazards event, and the capability to prevent or mitigate potential damage. Here are 3 steps on design stage.
Okay.
First is the inherently safe design measure. It prioritizes the elimination of hazards through design choices. Second is the safeguarding and complementary protective measures. If risks cannot be entirely eliminated through design, implement safeguards such as protective barriers, safety devices, or other technical measures to mitigate potential hazards. The third is the information for use. When residual risks remain despite design and safeguarding efforts, provide clear information to users. The one on user stage. First is the additional protective device. It is install engineered safety controls to mitigate residual risks during operations. Then the training provides comprehensive instruction to ensure users understand hazards and protocols, like certification program for forklift. Third is the organization of work, application of equipment, and supervision. Optimize workflows to minimize exposure. Then is the personal protective equipment. Deploy personal protective equipment as a last line of defense against unavoidable risks. The ISO Guide 51 outlines key principles for drafting safety standards to achieve tolerate risk levels. Standards should specify risk reduction measures and provide guidance on attaining acceptable risks, particularly during preliminary design, where some hazards may be intuitively mitigated. That's all.
You have found the original source of this original blue paper of guideline?
Yes.
Which site you have referred? Please show us. Got reference.
It's almost the same.
This lift up the scroll down. Reference. Please show your reference.
I have tapped it to the chart.
This part of the reference you should show. Yes.
I have.
This guide safe aspect guideline. You have access this site. This is only this guideline site. So therefore you have gotten the full paper.
I get it from the original.
Original?
ISO Guide 51.
Yes, from which site?
I have tapped it into the chat.
Chat?
In the chat.
Yes. ISO this site. This is freely available? I don't know exactly.
It's free.
Okay, ちょっと待って。これフリーにアベラブルかな? You also have found this? This is the same as the previous line? Previous one?
Almost the same.
Okay. Yes. So, thank you for your reporting. And then finally, I have to say briefly, what is the most important is this page. Yes. As Kenan says, the safety is a freedom from risk, which is not tolerable, not acceptable. So therefore, the freedom from risk is one definition. And then the most important point is inherent safety. So not controlled safety. This is we should do. But firstly, we have to try to do the essential safety. It means reduce the risk source as much as possible. Yes? And then the control safe. Inherent safe is better, but the functional safe or the control safe, if you have to do this kind of the type, the not danger detection type sensor should not be used. But the safety confirmation type sensor should be used because the sensor sometimes broken and make some failure. In that case, the safety condition situation detection is important to do something because this table shows that if the sensor is failed, it is stopped down. But the only safety is confirmed. It is safety continuing the works. But the danger detection type is only the dangerous is there. The machine can be stopped. But the others, the others case is continue to do, especially in the unknown or the sensor failed case is not moving and not stopping the dangerous machine. So therefore, the safety confirmed type sensor should be used. It's another important point. Yes, yeah, that's the point. 2 points you have to remember for this class. Okay. Yeah, thank you for today. That's all. If you have some question or something comment, please let me know in your supplementary report. Okay. Hi. Yeah, thank you. For next week, we will do some friendliness of the machine for the collaborative machines. Yes. Yeah. Thank you. See you next time. See you. Hi.